Hey guys, so in this opportunity I will be explaining to you why is the area formula the way it is, or in simple words, or maybe not so simple words, proving the area formulas of triangles, parallelograms, and trapezoids. Now we're going to start with the simplest, which is a triangle. Now, the right angle triangle, just like this, and this is the part where we know it's a base, and this is the part as we know as the height. And the formula given by the book usually is the area of a triangle. Let me put it there because it would be confusing if I didn't. Triangle is just half times base times height. Why is it like this? Let's draw additional lines here, and then another one right here. Okay, now this makes this a rectangle essentially, right? A square, a rectangle, same old, same old. A square is a rectangle, and this is also a right side. And as we can see, that this is the base just as well, and this is the height just as well, which makes this essentially the same two triangles, right? So there's 1 and 2 is the same. So therefore, the area of a triangle is just 1/2, because there's 2, right? So 1 is just 1/2. 1/2 of a rectangle, or the area of a rectangle, which means it's 1/2 of this. We'll just use base and height for this. 1/2 of base and height, and that's it. That's the area of a triangle. And then we'll move on to describe this part. The other types of triangle other than right angles, we're going to describe we're going to see why is the formula of a parallelogram the way it is. The area of a parallelogram, let me draw a parallelogram first. That's not good. A parallelogram. Okay, let's just say that this is a parallelogram, right? I can't draw, so please bear with me. And then we'll have this here too. This is a parallelogram, and this will be the base, and this will be the height. And then the area is just base times height. But why is it base times height? It can be confusing, right? This base times height is a formula for the rectangles, and this isn't a triangle, and this isn't a rectangle. So why is it the way it is? So let's just see this part right here as a triangle that we can probably just move here because it's of the same height, right? It's of the same height, and this length right here will just move right here, and that makes this a rectangle. Just like a rectangle, but with this part right here, this was the previous part, we just move it here, which makes it base times height. And that's the formula for the parallelogram. And we'll go back to the triangles. Okay, we'll use this. The various types of triangles. Say, it's like this, then it's like this, then it's like this. It's a triangle. So why is it the way it is? Why is it still half times base times height? Because let's draw this line right here. Let's draw this line right here. And that makes this just essentially like a parallelogram, right? And with this being the base and this being the height, this is also the same height, and this is also the same as this, the base, the height, which makes the area of this various types of triangle is just also half times base times height. Because why? Okay, it's easier right there. This is just half the area of a parallelogram, which means it's half of base times height. Okay, now let's go to the last part, which may be the trickiest and the challenging part, the area of a trapezoid. Now, a trapezoid, let me draw a trapezoid first, and please, again, bear with me with the drawing. Can draw. Okay, say this is a trapezoid, right? Okay, let's erase this part maybe. Okay, and this is B, and then this is A, and then we'll have the height here, which is the same as the height here. Height. And the formula usually given by the book is 1/2 height times a plus b. And why is it a plus b? Why is it this complex? Like, and compared to the rest of the formulas, why is it like the most complex? I mean, not the most complex, but and compared to the rest, yeah. And this, we can see here from here that if this is the height, if this is the height, which is the same as this, and here from here, it's just a, but it means that this part plus this part is the b minus a part, right? Because this is the what makes bb, a plus this part. So if we have to dissect this thing, this shape, we can make like this part plus this part, right? Because it has the same height. A triangle at this height right here. And the length of this right here is just, remember, this is b and this is a. So this is just b minus a. And this is the height. So the formula, as it's a triangle, is half times height times b minus a, right? I mean, this is the base, but because it's the base is b minus a, so it's b minus a, please. Okay. And then plus the rectangle, the middle part, which is base times height, plus base times height. Okay, base times height, I mean not just base, this is the b, so b times height, so bh, so the area is this, and then we'll combine the two, is, what do they have in common? So, okay, so again, this is how it is. We've gotten here so far, and this isn't b, I'm sorry. This is a, right? Because b is the whole thing right here, and a is just this. So this is a. This is a, and this is a, and then we'll do this part. This is hb over half ah. Okay, let's just do the same here. Bh of ah here too. Then we'll combine the rest. Half bh. Then this is minus half, and this is plus 1, so it's just plus half ah. Then we'll put out everything that's similar between the two, which is half and h, and then we'll have a and b is the same here, so a plus b, which is proven. This is equal to this. So that's it. That's the formula for a trapezoid, and I hope you guys understand what I'm trying to say here, and thank you for listening.